Welcome to Machine Shop Tech Talk, or welcome back to Machine Shop Tech Talk. If this is your first time here, don't forget to click like, click subscribe, and follow along. I interview world-class problem solvers, bringing you solutions, whether you need them today or maybe down the road. Today, we're going to get into the common thread between downtime, your part finish, and your tool life. But before we dig into that, I'm going to introduce my guest today, Cameron. Cameron entered manufacturing when he was 12 years old. He's been at it a while now. Then he went into the United States Marine Corps. He's got 2 years of Dynamic. Then he worked at DMG Mori, and now he is the National Sales Manager for Micron Filter Systems. Cameron, I'm so glad you're here today, man. We got to dig into how do those even come up? Because I'm thinking as a machinist, downtime, okay, well, I hate downtime. I don't like unplanned downtime. Part finish, yeah, I want to make sure my parts are finished to spec. And tool life, if I could just maximize my tool life, that's going to save me my consumable cost. So what's the common thread between those three things?
Well, I think the most general common thread between those three things is definitely the coolant. The coolant cleanliness and the, structure of it and how solid that coolant is going to help you keep the machine running, going to help you make those nice parts and also, prevent you from breaking tools or wearing tools a lot faster than you should be.
Like cleaning out my sump tank, man. I've been there elbow deep scraping the sludge off the bottom of my tank. You're not telling me I got to do that, are you?
That's a huge, huge thing when it comes to downtime is, whenever the machinist is doing that, from a foreman and an owner standpoint, it's just something that has to be done. But for the machinist, he's turning off that machine and he is doing the very worst job in the machine shop. Anyone that's done it, including myself, it's one of the first jobs that I had to do is, hey, we got to clean out this tank. We got to keep the sub pump screen clear, make sure we're running. So, I mean, it's a bad job. And it's realistically the main reason why we're turning off our machine and that machine is stepping away, especially in some nasty, aluminum applications. Those screens for those sub pumps get, full within a part or two. So, as opposed to focusing on making parts, your machinist is focusing on scraping out a tank, which again sucks. It's not fun. He doesn't like to do it. She doesn't like to do it. And, there's a lot more valuable things that they can be doing with their time rather than scraping out a coolant tank. Absolutely. Maybe they could be running another machine making more parts.
I've been there, right? Like I've run machine shops where we had to do that. But how do we get away from that? How do we avoid having to shut down our machines for 2, 4, maybe 12 hours, depending on how big your sump is? How do we get away from doing that, though?
Been around and been well known in this industry for decades. And it's paper filtration. Paper filter beds do the same thing for grinding machine and swish machines that they do for milling and turning and horizontal machining centers. It filters the coolant. So I think a really simple way to put it is right now we're running our machines or engines without an engine filter. So when you buy a Ford, your engine has a filter on it and it's automatically cleaning all the particulates that are created just by the running of the engine. So why aren't we doing that with our $250,000 machine tools? And really, it's going to bring you the exact same benefits as filtering the engine oil. It's just cleaning up the coolant, preventing all the problems that are associated with it, which are a lot more than what people actually realize.
The analogy to the car, because most people, if they're fortunate enough to be able to listen to us or to watch us, they're going to probably have a vehicle or at least have access to a vehicle. And it's something that, we all do. Nobody wants to be on the side of the road with a seized motor because they decided to bypass their oil filter. I don't think anyone bypasses an oil filter. There's a reason all vehicles that are internal combustion come from the factory with that, because otherwise it's catastrophic. I like that connection. And we're talking about the downtime aspect, but we kind of kicked it off talking about, part finish and tool life as well. So how does cleaning my coolant affect those two variables? Maybe start with part finish as the first one.
At PMTS, where I finally got to meet you after talking for so long, We are talking to a customer that is just locked in with the way that they clean their coolant, and he comes from not a manufacturing background, but more of an operations background, working for bigger companies like, Kellogg and crazy companies, to where when he stepped into a manufacturing role, he saw what was happening and immediately said, "Why don't we just clean up the coolant?" But anyway, long story short is he gave me a really good example. This is from a customer, last week. He said, take a really clean piece of stainless steel and then shoot a sandblaster at it. Whenever you look back at that stainless steel, you're going to see just the entire thing is going to be covered with damage, essentially. It's not going to be pure. Now, if we take a filtered air gun and we do that exact same thing, you're not going to see any divots or any finishing problems with that stainless steel. That's exactly what's happening with our parts is whenever we're cutting, using that cutting tool to actually remove metal from that part, there's inherently particulates and fines that are getting in between that part and that tool. So one, the tool is not doing what it's designed to do because there's metal in between the cutting surface and the actual part. So it's never going to perform to the standard that it's expected to because it's most likely not tested or at least given to the public with standards that are saying, hey, this is what happens after, a day of running it with dirty coolant. It's all clean coolant, perfect examples. And that's exactly what we need to get to is if I go to a tooling rep and ask them what's the most important thing that a machinist can do to keep their machine running and keep the tool life long, the very first thing they say is clean the coolant. It's keep the coolant consistent at a temperature, clean the coolant, everything's going to work better. And that's exactly it is when you have less particulates in the actual coolant, the tooling is going to touch less metal, it's going to cut longer, it's going to cut more precise. And then, with the finishing, there's just going to be less things to affect the finishing. So stop spending more money on more expensive tooling and more expensive work holdings. Let's just clean up the coolant, see if that can get you back to square one and see if that fixes the problem instead.
Things people can take action to right now. They could go and use whatever system they have to dump out their tanks and just clean their coolant and look at the change the next day. Obviously, there's fantastic solutions like the Micron systems, and we'll talk about those in a little bit, just because I'm curious about some of the details there. And I'm sure people watching right now or listening right now would also have a little bit of curiosity there. But when you're talking about like the just that sandblasting, man, I can't imagine sandblasting the edge of an insert or an end mill and then being confused as to, oh, why isn't this end mill working? I would know darn well why that end mill wasn't working, why that insert, was wearing out prematurely, and I was starting to get that filmy kind of marred finish on my turn parts. It wouldn't be any there would be no question, right? It would be very, oh well, I sandblasted the insert, of course, but I didn't really think about the effects of having the particulates suspended in your coolant and just constantly attacking the parts and the cutting tools. It makes a lot of sense.
That, I mean, we're talking about the high pressure coolant system that's feeding it. That thing is not designed to have metal shards flowing through it, you know? The pumps associated with the machine, I mean, the spindle, it's just there's so much affected. You're absolutely right.
In shops, and if you're a shop doing this, don't. But their bright idea, because you were talking earlier about how the filters on the sumps get plugged so quickly, their solution to that was to remove the filters. Now, the end result of that was 6 months later, I was then disassembling the machine tool, because all of my tubing and inside the head of the machine, everything was completely caked. It was disgusting. I don't recommend it. It was like the slimy jelly stuff that started, because now I'm taking all of the crap and I put it inside the head, like in the coolant delivery system. Not a great call. I didn't have to clean the sump for a little bit. I didn't have to clean the basket for like 6 months. But then I had a whole other issue. My machine was down like 3 days or something stupid. It was a bad time. I don't recommend it. If you're doing that right now, put the filter back on. You're gonna make some headaches. You're talking about filtration units. What do you say to the people that say, "Oh, that's just for grinders because they have a lot of fines"? Like, what do you say to that kind of human? Because I'm sure they're listening right now and they're typing angrily into the comments.
I would say look at some of the other hubs around the world for manufacturing and see what they do. Because if you go to a Japanese manufacturer, the coolant on their tool room machines are going to have coolant filters on them. If you go to Europe, it's standard practice, and it's because you know, they've seen the benefits. They're buying machines at, 25% less rates. They're not having to replace the way covers, the ball screws. The only reason that way covers and ball screw repairs happen is because the fines in your coolant break down the seals in those way covers. Once those way covers are broken, the particulates in the fluid is getting into the guts of the machine, and that's what causes these 25, $30,000 repairs. I mean, it's just endless. So if you were to put a $6,000 filter on your $250,000 machine prior to it breaking down the first time, you're going to most likely not ever gonna have to replace the weight covers, the ball screws, or anything like that. But you're also going to get all the other benefits. I don't know if I answered your question very well or not. I think I might have gone off on a tangent.
When you look at that example, a $6,000 filtration unit on a $250,000 machine tool, we're talking like 0.02% of your machine tool cost to prevent it wearing out and having to spend another quarter mil or 100 grand in repairs or downtime or all of the other stuff. I had my buddy Taylor Goodyear from TGCNC service on, and he was saying, he's like, man, he's like my number one money maker for shops is I walk in and I pull back their way covers. And he's like, most of the issues are usually inside of there because, like you said, the seals have broken down and chips now have been packing in under there. He's like, 9 times out of 10, if I get an issue with a sensor, he's like, I pull those back, I clean out 20 metric tons worth of chips, and suddenly the machine tool's working again. If they could put a filtration system on there so it doesn't break down the seals, so they don't pack their ways full of cool chips, that just sounds like a no-brainer. Like you said, it's replacing the oil filter on your car. Like it's that cheap of a thing. Because I mean, an oil filter on a car costs what, $30, something like that. It's that 0.02% of the car, and it's totally worth it every
Yeah,
single
it's
time.
just and I understand it because I spent a decade selling machine tools for some of the best companies in the world, some of the best machine tools in the world, and it was never a stress point for us to put coolant on. It was really, do everything to get the machine in the user's hand and whatever they want to do, let them do it. And also, it's a very competitive industry, and adding an additional $8,000 to a deal could be the difference between you and your competitor kind of getting it. But if we just take the time to explain to our customers this $8,000 is going to save you hundreds of thousands of dollars throughout the, 10, 20 years life of the machine tool, it's really a no-brainer. It's more just getting people to understand that we can either kind of sit back and keep rebuilding our machines and keep spending this money on better tools and simple repairs, getting our guys out of the coolant tank, or we can just kind of handle this from the beginning, never have to worry about it again.
Lot to be said about handling it from the beginning. I mean, let's be real. Neither of us are selling machine tools right now. So the reality is if that machine tool starts giving you grief earlier, it also means you've got a customer possibly coming back and looking at a new machine tool sooner.
Well, or you got somebody coming back and looking for a different machine tool that'll run a little bit longer. We'll have these problems that quick. And that's something that I stress to my builders is, hey, if you can extend the life of this machine by 25% without them needing to do a major repair, do you think that they would look at you a little bit harder versus a competitor?
It's kind of a good place to kind of tie up our conversation. The end results, people, if you've somehow fast forwarded to right here in this now moment and you skip the conversation between Cameron and I, if you filter your coolant, you're going to eliminate unwanted downtime. You're going to eliminate poor part finish, and you're going to eliminate excessive premature tool wear as well. And these are three things that most machine shops don't sign up to have struggles with on the daily. Also, if you stuck it this long in the conversation, this is a great point to just go down and find the like and the subscribe button. I would really appreciate it. But Cameron, let's say people are like, look, yes, I want to figure this out. I mean, when you say 6 to 8 grand, that's such a stupid small number to me. As I've been selling to manufacturing, I sold for 8.5 years to manufacturing, and before that, I was a machinist. That's such a stupid small cost compared to some of the downtime bills and the repair bills and everything I've had to do. So if they want to find out more, I'm going to put links to whatever you tell me to put down there later. But is there some specific call to action or some specific way you could share with them right now to reach?
You can come to our website, micronfiltergroup.com. That is our American landing page. You can find all your information there. You can contact us through the website. You can also find me on LinkedIn. My name is Cameron Murray. Um, Contact me. I'm sure he'll put my phone number down below. But realistically, it's just coolant filtration solves, I would say, 80% of the problems that machine shops and manufacturers have. If you're having troubles, just call me. It's worth the conversation. At least you'll understand a little bit more of what you need to do to just get back on track and see if it is a good fit and it can help.
About just selling them to everyone. It's about discovering. Does it make sense? Probably, but we won't know until you have a conversation. Well, thank you so much, Cameron, for sharing your expertise with the listeners today. And to my machining friends out there, keep your spindles turning and earning.